Alright, for this we're gonna start talking about equations. For our grade 9 level, we're gonna focus on three types of equations. Linear equations, exponential equations, and quadratic equations. This video is only gonna focus on linear equations of varying difficulty. There's about 27 examples that I'm gonna do. Each one of those examples is gonna be slightly harder than the next. There might be a bit of repetition just to make sure we're okay, but let's go ahead and get into it. Linear equation, by the way, is an example of 2x plus 4 is equal to 10. Alright, basically the highest exponent is 1. There's no exponent higher than 1. That makes it linear. There's three universal steps or general steps that we're going to follow. Step 1, we won't see it until later on, but it says to simplify everything, which means we're going to get rid of brackets. We're going to apply some products and some multiplication and whatnot, but we'll get into that. Step 2 is the most important idea. With a linear equation, the easiest thing, the most important thing is always to put all my terms that have an x on the left and the terms without an x on the right. Now, this is the simplest way to do it. Obviously, there are a few considerations. Sometimes you can have the x on the right. It's not a biggie. But generally, when we're learning it for the first time and when we're practicing it at a introductory level, we just try to follow this to make sure that our understanding develops a little bit better. Okay, it helps us to build that confidence to do things that we talk about later. So put all my terms that have an x on the left and all the terms without an x on the right. Simplify both sides and solve. Now I've left that a bit vague, step 3, but I'm going to explain it through practice. Here's an example, right? X plus 2 is equal to 5. This is the concept of trying to put things on one side and try to solve them. In this example, we see that we have an x on the left and a number on the left, and we've also got a number on the right. Now, with an equation, the first thing you're always going to do is remember that there's only one equals to sign in an equation on each line. You cannot have two equals to signs on any line. That would be incorrect, immediately incorrect, and you should lose marks for that. So where does that equals to sign go? It goes directly below the previous equals to sign. This allows us to have a sort of half that we look at, and we know there's a right hand side and a left hand side, and you can work through that. So equals to sign in the middle. Now I've identified a problem. There's a number on the left when I only want variables or x's on the left. I don't want that number. So this is an anomaly, or basically a problem. So I understand that that's an anomaly. Everything else is okay for now. Well, I'm not touching anything else for now. So I'm going to bring it down as normal. For the sake of making it easier to follow, I've put them directly below where they came from. So x below the x and 5 below the 5. Now, what do I do with this anomaly? Well, it's got to go across the equals to sign. That is a rule that we use here. When I move something across the equals to sign, when I move an entire term, so now this is an entire term because it's been separated by a plus. So I'm moving an entire term across an equals to sign. The important thing I'm going to do is I'm going to change the sign of that term. So it was a plus 2. It's going to become a minus 2. Alright, so that's all I've done. I've moved it across and I've changed its sign. I'm then going to put the equals to sign that belongs on the next line. Bring the x down. Now, 5 minus 2, well, that's 3, guys. So 5 minus 2 is 3. So I'm done. I've written x equals 3. Once I see something like this, I'm done. I want x alone. There should be no coefficients. There should be no exponent. There should be nothing. It's just x equals number. I'm happy. All right, let's go for the next one. Same concept. Equals 2 underneath it. Anomaly identified. X brought down, 8 brought down. Move it across. What do we do, guys? When you move something across the equals 2 sign, when you move a term, yes, you change the sign. So equals to x, 8 plus 3 is going to give me 11. There you go. Again, equals to sign. Let's bring the 7 down. Oh, please guys, let's pause the video and attempt these questions before I attempt them, so that you know that you can do it without watching someone do it all the time, and you build that confidence. This is what it's all about. Confidence in mathematics is one of the most important things, and you've got to have the confidence that I know I've done it before, so I'm gonna be able to do it again. So anomaly, move, change sign, +1 equals to sign underneath it. X equals to 7 plus 1 is 8. Perfect. Equals to sign. Anomaly identified. So let's bring this down. So I'm going to have x and 2. Bringing this across will become -4. Equals to sign under the previous equals sign. X 2 minus 4 is -2. Right? First 4 done. Alright, we have a slightly different situation here now. So now I don't have something being added or subtracted, so it's clearly not that same situation. But now I realize the problem is this. There's a 2 in front of my x. Why is there a 2 in front of my x? We need to understand why are things where they are. What is happening? What is the reason that it is there? Alright. So when we discussed expressions before, we said that if you have a number next to a variable, it means they are being multiplied. So 2 is being multiplied to x. Now I need to undo it. Remember, an equation is something that is balanced. There's equality happening on both sides. So 2 times the number is equal to 8. So in order to get this number, I've got to halve it. Basically, well, the trick we do here in this case is when there's a coefficient to my variable, whenever there's a coefficient, we put a line under both sides there and we divide it by whatever that coefficient is. Now I'm going to put my equals to on the next line. So you realize I've skipped this line because this is not an equation. That's the division happening. So my equals to goes to that line. And then I have a look now. So what happens on my left hand side? Well, the 2's cancel. I'm left with x. So that was the whole point, to get x alone. So I did it by dividing it by the coefficient. And on the right hand side, 8 divided by 2 is 4. Alright, pause the video, try the rest. Let's go. So the second one, anomaly identified. Divide both sides by 3. Bring my equals to sign over there. 3 is cancel. X is equal to 6 divided by 3, which is 2. Next one. Divide both sides by 5. Bring my equals to. X cancels. X is equal to 2. Next one. Alright, so this time there's a negative here. Let's divide both by -2. Equals -2 cancel. X is equal to 6 divided by -2. Positive divided by negative is a negative. 6 divided by 2 is 3. Alright, let's carry on. Again, same story. Pause, try. Pause, try. Keep it going, guys. So divide. -3, -3. Equals 2 on the next line. These cancel. I'm left with x. Negative divided by negative on the right is positive. 15 divided by 3 is 5. Alright, just mind my 5s, guys. Alright, next one. So in this case, -x equals -10. The idea is that it's still an anomaly. Well, the coefficient here is -1. So divide by -1, -1, -1 cancels, and x is equal to +10. Right. Again, same story. There's a -1. Divide by -1, divide by -1. They cancel. X is equal to -8. Alright? This is a bit trickier, but there's two problems now. There's this and there's this. What do we solve first? So the idea is, whenever you want to do this situation over here where you've divided by the coefficient, it's gotta only be that one term on the left hand side. So I cannot divide by 2 here, because would I be dividing the whole thing? Divide this. I need to simplify. I just need to have 2x equals to something. So the main thing I'm going to treat now, the main problem here is this. That's going to go across there. So this 2x will come down for now, equals 11 minus 3. And then we'll say 2x is equal to 8. Then we can treat this by dividing by 2. And they cancel. X is now equal to 4. That's solved. So we treated them in 2 steps, all right? So it's supposed to be done that way. You take a few extra lines and there's a few extra things to do, and that's all right. Remember to pause the video and try these. It's extremely important that you attempt these on your own. Treat this first. So if I take that across, I'm going to have 4x equals to minus 2 plus 6, which is going to be equal to 4. And then I'm going to divide both sides by 4. And x is equal to 1. Remember that those 4's cancel. Alright? Okay. Perfect. Let's go again. Alright. Treat this first. So equals to 3x minus 12 minus 9. Remember to change these signs when you take it across. Then 3x is equal to minus 21. Divide both sides by 3. These cancel. X is equal to negative 7. Alright. Making it a little more interesting now. So we said we're gonna treat something first. Would I move this across? No, that's the x. The x needs to stay on the left. The term with the x needs to stay on the left. So this doesn't move. That'll stay the same. So let's bring it down for now, right? Now, the thing that needs to be treated here is this. So that's going to go there. So 22 minus 7. So minus 5x is equal to 15. I can divide both sides by minus 5. And these cancel. So x is equal to negative 3. All right. Next one. Now, here's one of those situations. The x is on the right-hand side. So what do? Well, we can move it to the left because that's what we said we want to do in the first place. But we don't have to. So what I'm going to do now is I'm going to show you how to do it without moving it. So let's have a look. The equals to sign, well, it's going to stay there. The 4x is going to stay there. And the 5 was there. This negative 7 gets treated by being moved across. So it's going to become a positive 7. And while the 5 had a plus, so it's plus 5. So 4x is equal to 12. And then I can go ahead and divide both sides by 4 because I'm treating this. And then x is equal to 3. So it's fine if it's 3 equals to x or x equals to 3. That is 100% correct. Now, let's talk about moving things now. We have 2 treatments to apply at the same time. Number 1, this needs to go there. Number 2, this term where the x is in the wrong place, it's going to come over here. So, let's bring the equals to the 7 and the 6x. The minus 3, well, it's going to come over here as a plus 3. And the plus 5x is going to go as a minus 5x. So we've moved 2 things at the same time to where they need to go. 6x minus 5x is going to be x, 1x. And 7 plus 3 is going to give you 10. So my answer for x is 10. Right. 4x minus 8. Pause the video, try it. So this will go over there. And this will go over there. So equals to 4x is not moving, and while the 3 is not moving. The negative 8 will become a plus 8, and the 6x that was positive will become a negative 6x. So now on my left hand side I should have negative 2x. On my right hand side I should have 11. Now I need to treat this by dividing by negative 2 on both sides. x is equal to negative 11 over 2. Right, so sometimes you're gonna get a fraction. That's all right. Okay, that's all right. So yeah, there we go. Next one. Now there's nothing to treat on this side, so it's okay. We don't focus too much on that. Don't stress on the small things. This needs to move though. So equals to, well, we got a 2 here. We got a 2 here. The 5x is here, and now we're gonna have a minus 4x. And 5x minus 4x is x, and well, x is equal to 2. Straightforward. Nothing too heavy there. Pause this one and try it. Equals negative 2x. I'm going to bring that down, and negative 7, I'm going to bring that down. This needs to move and become another negative 7, and this needs to move and become a negative 2x. That means I have negative 4x equals to negative 14. Divide both by negative 4, and x is equal to positive, because negative divided by negative is positive, and well, 14 over 4. Or if you simplify that fraction, it's 7 over 2. Alright, okay, just a few more to go, guys, but difficulty level has been increased. Now this is where step 1 comes into play. Get rid of brackets. That's what we're gonna do. Let's take pink. How do you get rid of brackets? You've got a bracket here. We're gonna take this 3 and multiply it into there and into there, and the 4 into there and into there. So the rest of the equation won't change. So this is an equals, then there's a 6 over here, and now we need to figure out that multiplication part. So now positive 3 times x is going to be plus 3x. Positive 3 times negative 2 is going to be minus 6. 4 times x is going to be 4x, and 4 times 1 is going to be 4, equals to. Let's treat. This needs to move. This needs to move. This needs to move. So the 3x is over here, and the 4 is over here. That 4x from the right hand side is going to become a minus 4x over here. From the left hand side, the positive 6 is going to become a minus 6, and the minus 6 is going to become a positive 6. Now 3x minus 4x is going to be negative x. 4 minus 6 plus 6 is 4. Divide both by negative 1, and x is equal to negative 4. Now that we've done that one together, please pause the video and attempt this one. Yeah, even though it's slightly trickier. So in this case, we've got a negative 1 coefficient. This goes there and it goes there. Rest of the equation doesn't change. So 2 minus 5x, 3x. Now let's see what happens. Negative times x is negative x. Negative times negative 4 is positive 4. Identify things that need to move and start moving them. 2, 3x minus x. Now the minus 5x will become a plus 5x, and the plus 4 will become a sorry, let me just put this in green. Plus 5x, and the plus 4 will become a minus 4. So that's equal to negative 2. 3x minus x is going to be 2x, plus 5x is going to be 7x. And then you can divide both sides by 7, and x is equal to negative 2 over 7. This one's a bit more trickier, so let's see what's happening. Number 1, this squared means that that bracket can be written twice. So basically it's 2, well, let's use a different color. Let's use blue here, right? So it's 2 bracket x minus 1 bracket x minus 1. It can be written twice. The rest of that equation stays the same for now. I always do one thing at a time. If you've noticed, I try not to do two different things at the same time because you can make mistakes. At some point you will be able to, and that's all right. But for now, while you are learning and practicing and mastering this, do the slow boring way, because that's gonna build consistency, that's gonna build the perfection, that's gonna build the ability to do it every single time correctly. And when you start doing it fast and skipping steps, and even if you make a mistake, you will realize you've made a mistake. Now we're gonna do FOIL. So FOIL means I'm gonna take the first term here, multiply it there, then that term times that. And then I'm going to take this term times this and this term times that. Same thing on the right hand side. I'm going to do this. I'm going to do that. I'm going to do this. And I'm going to do that. The equals to sign still over there. This 2 for now is going to be there. And it's going to be multiplied to whatever that FOILed answer is. So I'm going to just put it there for now. Right. On the left hand side, x times x is x squared, and x times negative 1 is negative x. And then negative 1 times x is negative x, and negative 1 times negative 1 is plus 1. On the right hand side, 2x times x is 2x squared. 2x times 1 is, well, 2x. Negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. Now, whenever you do FOIL, these terms in the middle are always like terms, or there's at least 2 like terms. So we're going to sort that out first. So equals to 2x squared plus 1. So notice how everything that isn't changing is in black. Alright, so minus x will become minus 2x. That's a bit hard to read, so let's use this. Minus 2x and plus 2x minus 3x is going to become minus x. We're then going to distribute the 2 into the brackets. So there, and there. So this will become 2x squared minus 4x plus 2, and that's equal to 2x squared minus x minus 3. Now we're moving things across. So this is going to go over, and well, this one and this one is going to come to this side. Right? Equals to. So I've got a minus 3. The plus 2 will become a minus 2. On this side, I have 2x squared, and I have a minus 4x, alright? The minus 2x squared from the right is going to come across and become minus 2x squared. And the minus x is going to become a plus x. Now, the thing that happened here that made this still a linear equation, even though there's an x squared, is that the plus 2 and minus 2 cancel. On the left, I will then be left with minus 3x. And that's equal to minus 5. Alright. So that's equal to minus 5. Then I can go ahead and divide both sides by minus 3, and x is equal to positive 5 over 3. Alright, so pretty straightforward, but there is a bit of a learning curve there, so we've got to make sure we know what we're doing. Alright, now for this one, fractions, right? So you should expect to be ready for fractions. In order to solve equations with fractions, we're going to start by making sure everything is a fraction. If there's no fraction, make it a fraction. So in this case, the 3 becomes 3 over 1. Now that we have all our fractions, we're going to look for something called the lowest common denominator, the LCD. So LCD is basically the LCM of your denominators. So what are our denominators? Well, our denominators in this case is 2, 5, and 1. So what's the lowest common multiple of 2, 5, and 1? So if you do the multiples of 1, well, 1 is every number. 2 is 2, 4, 6, 8, 10, 12. 5, we have 5, 10, 15, 20. 10 is a multiple of all three numbers, basically. You can get 10 from all three numbers. So our LCD is 10. Now that's important. We're going to take our LCD and use it to make all our denominators 10. Starting from the first one. Our first denominator is 2. So we're going to multiply this by something to get 10. And 2 times 5 gives you 10. So we're multiplying the numerator and the denominator. Alright. Then the next one is 5. 5 times 2. So you're going to multiply the top and the bottom. And the last one is the 1. So 1 times 10 and times 10 on the top. I'm then going to put an equals to sign on the next line and write all my new fractions. So x times 5 is 5x over 10. I then got this minus that hasn't moved. X times 2 is 2x. And then over 10. And on the right hand side, I'm going to have 30 over 10. Now that all my denominators are the same, I ignore the denominator, but the way we actually do this is we say we're multiplying both sides by the denominator, which allows us to negate them, which you should show. But the concept is that if you multiply this into this, the 10s cancel, the 10s cancel, the 10s cancel, and all you're left with is this new expression that looks like this. So equation 5x minus 2x is equal to 30. And then you can solve that. So 5x minus 2x is 3x, and that's equal to 30. And then we can divide both sides by 3, and then that's x equal to 10. Alright. You should pause this and practice this. It would be beneficial. Now, we'll begin putting that over 1. Then, LCD between 2, 3, 1, and 6 is going to be 6. Multiply. Times 3, times 3. Times 2, times 2. Times 6, times 6, times 1, times 1. Equals equals to sign, plus, minus. I'm gonna have, well, 3x times 3 is gonna give me, let me just there. 3x times 3 is gonna give me 9x over 6. 2 times 2 is gonna give me 4 over 6. X times 6 is gonna give me 6x over 6, and then I'm gonna have over here 5 over 6. Then, as we did before, we eliminate the denominator just by showing we're multiplying both sides by the denominator, and we'll be left with the numerator. So 9x plus 4 is equal to 6x minus 5. Then we spot our anomalies and we sort those out as usual. So this is common at this point. So 9x negative 5, the plus 4 will become a minus 4, and the plus 6x will become a minus 6x. That's equal to negative 9, and that's equal to 3x. Divide both sides by 3, and x is equal to negative 3. Alright, now for this one, we have a slightly interesting situation. Before we begin, I want you to just go ahead and put a bracket around those numerators. And I'm going to think of this as 1 fraction over 1. Alright, so 1 fraction over 1. I can then find my LCD as 2, 3, and 1. My LCD is going to be 6. So multiply this by 3. Now I'm going to multiply that whole bracket by 3, all right? Which means it's going to go like this. Then I'm going to multiply this one by 2 and that whole bracket by 2, and this one by 6 and that whole bracket by 6. So my new fractions are now going to look like this. So 3 times x is going to be 3x, plus 3 times 3 is going to be 9 over 6, minus, now 2x, I'm still going to keep the bracket for now, right? 2 times x is going to be 2x, and 2 times negative 2 is going to be negative 4. Keep that bracket over 6, and on this side I've got 6x minus 12 over 6. Now eliminate the denominator by multiplying both sides by 6, and I'll be left with 3x plus 9 minus 2x minus 4 and 6x minus 12. Now the reason we kept the bracket was because of this negative sign. It's going to be distributed over here. And the reason I kept it is because if I didn't have the bracket there, it would have just looked like that was a normal negative 2x, and that would have gave you the wrong answer. So I'm just going to change that negative 2x plus 4. So the negative sign changed those two. The rest stays as normal. Those brackets were not necessary, but I just kept it across the board just in case and just to show you how it looks. Equals to isolate. So you are gonna go, you gotta go, and you gotta go. So on the left hand side, 3x minus 2x minus 6x. On the right hand side, negative 12 minus 9 minus 4. So let's just move this a little down. All right. Do I have enough space? Okay, that's fine. Right. So let's get back into this. So 3x minus 2x is x, and x minus 6x is gonna be minus 5x. Negative 12 minus 4 is gonna be minus 16. Minus 9 is gonna be minus 24. All right, so that's gonna give me 25. 16, yeah, 25. So that's gonna give me negative 25. Divide both sides by negative 5. Those cancel. X is equal to positive 5. Right. This is the last one for this video. If you've managed to watch the whole thing, well done. Okay, so for this one, our LCD, well, there's nothing to it. Our LCD is just gonna be x, because x is what our denominator is. So these two remain the same. This will simply just get an x, so we'll have 3x 3x over x plus 10 over x equals to, I'm gonna also go ahead and distribute this 2x plus 10 over x, and then we're gonna get rid of the denominator by multiplying both sides by an x. I'll be left with the numerators, which are 3x plus 10 and 2x plus 10. All right, our anomalies here are this and this, so equals to, this equals to 3x 10 minus 10 over here and minus 2x over here, and that's equal to 0 and x. So our answer is x equal to 0. There's just one question though, one consideration now. In this question, in the original question, x was a denominator. That would mean, that would now mean that this value for x, which is 0, should go as a denominator. Now, if you imagine something like, well, let's say the 10, for example, this one here, this 10 over x. 10 over x is now equal to 10 over 0. And what does that mean? What's 10 divided by 0? Well, it's undefined. You can't have a number that is divided by 0. It doesn't exist. It's a problem. So x being 0 is a problem. So our answer is going to be x is, well, it's not equal to 0. We found through calculation it's equal to 0, but that's not the case. It doesn't work. It doesn't give us the answer, so we just gotta eliminate it and just say that that's a restriction, and it doesn't work. All right.